All right, this is a quick conversation about prepping your data for efficient analysis and visualization in Tableau. I do think that the idea of tidy data is easiest to understand after you've encountered and tried to work with untidy data sets. So take this short introduction and work on applying the concepts as you explore your own data this semester. All right, so tidy data means that each column or field of data represents a single variable. So for example, if you had a field with city and state, you would need to separate it into two fields, one for each variable. And I'll show you how to do that in a second. The second requirement of tidy data is that each row needs to represent a unique observation. So watch out for things like table titles, narrative descriptions, aggregations. You see this all the time. In this example, the data have been organized and labeled in a way that makes it really easy for a human to read. But look at all the cells that contain information that don't directly describe the values stored in the cells below, like California, New York. Characteristic, here we have age group and average numbers of movies are the subgroups of characteristic, but it's all in the same column. That doesn't work. This is very untidy data. The third requirement is that the data set be complete, or at least that all the cells are accounted for somehow. Here's an example that we're going to revisit in a bit. 4 employees and the parking fees that they've paid on different days. We have to consider what empty cells means. No data is different than 0. In this case, where the cells are the amount of parking fee paid, $0 might be an appropriate value to fill in. But what about this data? This is from the World Health Organization. It's data on the percent of a country's population that's using safely managed drinking water. The Congo doesn't have any values for 2022. But does this mean that no one was using safely managed drinking water, or that maybe no data was collected in 2022? We can't just fill empty cells with zeros to make our data sets complete. That's going to impose some bias. Another way to think about prepping data is to think about tall data versus wide data. And here's what I mean. People-friendly data is often captured and recorded in a wide format with a lot of columns. I'll show you an example. Data with fewer columns and more rows is actually preferable for machine reading. And because we're going to be using machines to work with our data this semester, we're going to think tall data is good data. Tall is good, wide is bad. Here's why. This is World Health Organization data on malaria, recorded malaria cases. There's a column for country, and then there's a column for each year. Every cell represents the number of cases of malaria reported for that country in each year. It's an easy way for a person to read and understand data when it's structured in a format like this. This grid structure is very logical for us. But for machine reading, it's difficult to analyze across time because the data is stored in separate fields. The reported cases of malaria are stored in columns, and the columns contain the same kind of information over and over again. The clearest way to detect this is to ask whether the column header is describing the value contained in the cells of the column or field. Nowhere in this table do we have information about what the actual values mean. For example, in Algeria in 2012, we have the value of 55. Well, 55 what? 55 2012s? Of course not. It's not clear from the column header what this value means, and that's an indication that this data needs to be pivoted. The field header is a year, but the cell value is the number of malaria cases. So we have basically two different descriptors in the same column. If we bring this data into Tableau, you would see that each year field is listed as an independent measure. We have a field for 2000, a field for 2001, a field for 2002. But there's technically no measure describing the number of reported cases. It isn't possible to display the change in reported malaria cases over time when each year is listed as its own measure. Instead, we'd want to have a measure of year, and then each one of these would be an independent descriptor of year. This data set has 108 rows, one for each country, and I'll show you why that's important in a second. Okay, pivoting the data means we reshape the data from wide to tall. A pivot typically changes columns into rows. So now this is the same data, but rather than having a column for each year, we have a single column labeled year. And hey, look at that, the column header actually describes the value contained in each cell. And we have a new column, reported cases, which again describes exactly what the cells in that column are representing. To accomplish this, we had to duplicate the country's name, one for each year and reported case. So in this format, we have around 1,600 rows, which is basically, roughly, the number of countries multiplied by the number of years columns that we originally had. Now this data format is taller rather than wider, which is good for machine reading. Looking at it in Tableau, there we go. Now we have dimensions of country and year, which is appropriate, and a measure for the reported cases. This is something that we can work with. Here's another simpler example. The problem is the same though. There are 5 fields that all represent the parking fees paid for that given day. And then there's 4 employees listed. The column header is a date and doesn't describe the value in the column cell, which is a dollar amount. Pivoting this data will make the spreadsheet taller than it is wide. And I want you to take a minute to think about what the new table will look like. How many rows do you think there'll be in the pivoted table? Well, it kind of depends on whether the cells with no data are going to be counted. Should those cells contain a 0? If so, the pivoted table will have 20 rows, a row for each person and for each day, or 4 employees times 5 dates, or 20. But if the cells without a fee are not to be included, then there will be 10 rows, because Christine paid a fee every day, but Tristan only paid a fee on one day. So there's just fewer rows in the output cell. This is the preferred data structure for working with spreadsheets in Tableau. It meets all the tidy requirements. Okay, as a reminder, columns containing multiple descriptors need to be split to be read correctly by our trusty computers. And in this case, the airline name you can see has been combined with an abbreviated identifier, and we need to split those into independent columns. In Excel, this is called text to columns. It's found in the Data Tools section. And a wizard walks you through the process of splitting those up. You can see here year and semester is being split now into year and semester. I did have to rename the column header for semester. In Tableau, it's even easier. The command is named something really obvious like split. You do have to rename the columns in Tableau as well. But really, that is data prep in a nutshell. And the greatest thing is that Tableau's data interpreter is brilliant. It does much of this for you. It's good to know what's going on behind the scenes. So that's it. Have fun playing with your data.